For the project description, so instead of costly sensors as normally are used for traffic systems, our project is a camera-based, which is more affordable, easier, and cheaper to install, which is based on our project. The camera is used to detect vehicles and intelligently switch the green light when the remaining sides are clear, which normally you wait like in an intersection around 4 to 8 minutes. And it's pretty tedious, which we want to make it feasible for the users to be able to cross the intersection, since there's 4 intersections. Yeah, so cutting the wait time on red light significantly, no road excavation and minimize time-consuming road work. Project benefits, so enhanced traffic efficiency, which makes users wait long. They don't have to wait long periods of time in that certain intersection, waiting 4 to 8 minutes. Less traffic, affordable solution. However, that depends if you have your own business. But since I'm not sure for the traffic system company names, but it's actually pretty costly. But in terms of our project, it's more affordable. Environmental impact reduction, which is gas-powered cars, as you can see right here, Mustang cars. Well, it doesn't have to be Mustang, but just gas-powered cars. They throw a lot of CO2, and when users are just waiting in that intersection, the more time they wait for the traffic light to turn green, the more pollution increases, which we want to reduce that problem. So less pollution. Project components. So these are the following components that we use for the traffic light system, which was the Raspberry Pi, for sure, LEDs, and then the camera, ultrasonic sensor, which detects the distance for the values of the object itself. The breadboard, the wire and resistors, more to power it. Simulated environment, which I created a miniature paper intersection, which we will be demonstrating at the end of this presentation. And then the car model.
Okay, so how can we use camera to detect a car without any expensive sensor? So the presumption is that if Tesla can use camera to drive the car, so why can we use camera to do a simpler thing, right? So here is the basic logic of our project. So when the camera starts and we read the image from the camera video and convert the image to another format. So this is required by TensorFlow, an AI platform, TensorFlow's object detection function. So we use that function with the image as the input, and it will output the detected object automatically from the image. So is it amazing? And so now here is that we get the detected results, right? And at the same time, we will use the ultrasonic sensor for another direction, because we only have one camera available. So we use this ultrasonic sensor to get the distance for another direction. So we can say if the distance is larger than a certain value, we can say, oh, that direction is clear. No pedestrian is walking by. So if less than a certain value, we can say that direction is busy, somebody is there. Okay, and so now we have the detected result, and we also have the distance information for another direction. So we can just use a loop to iterate each detected object to see if that object is a car. It's a car-like object. If that's true, and ultrasonic sensor, the distance is larger than certain value, it's clear. Okay, is this two condition met? So we can say, okay, turn on the green light for 5 seconds, let the car pass. So you're waiting here, right? No other traffic on the other side. So you can just go, saving the driver's time, right? And otherwise, we just run the normal traffic light system. Yeah. And here is the code, the most important part, coding part of my project. So our project. So here you can see it's based on the same logic in the previous block diagram. So when the camera is open, it's running and read the image, prepare the image, convert the image to another format for the TensorFlow detector algorithm. And we get the detected result and multiple results. And at the same time, we will get the distance for another direction here. Yeah, and in these two for loops, we just look through every detected object to see if there's a car-like object. If so, turn on the green light for 5 seconds. If not, just run the normal traffic light. It doesn't hurt, right? Okay, here is the traffic light controller where I used to control the LED light. And I put it into a class, so it's more modular, convenient to use. And that one is the ultrasonic sensor used to calculate the distance. And here, I'd like to show you some photos. And in the early stages of our project, we're testing the LED lights, and here we're combining the camera, Raspberry Pi, and the LEDs to test our algorithms, because we are not so sure if this will work or not, you know. And the testing stage, and we are testing the camera here. We are actually control the toy car moving toward the camera to see if it works. And I have the actual video we are testing there. Yes, moving toward the camera. Okay, we're testing it. Okay, it's the first stage. And okay, this is the actual image from the Raspberry Pi. And I don't know if you can see here, there's a car detected with 31% confidence level, and it's running on 3 FPS. Don't play again on this, but 3 FPS actually does the work for our simple traffic project. So, and I actually have the video showing our Raspberry Pi running the algorithm in real time, capturing the objects. You can see a little bit slow, but if you detect a car, a truck, sometimes, I don't know why, but yeah, it's quite accurate. 41%, 43%, 46%. Okay. Thanks to our team member, George, we completed the paper miniature. And so we are able to simulate the real environment as real as possible. And okay, here we are putting all the things together. You can see here the traffic system was not assembled yet. We are testing it. Remove the object, detect the car, turn green. Okay, turn green. See that? And yeah. And the second beta version, so we assemble the traffic light. It's the same concept. So yeah, same concept. Normal traffic condition, normal now, and remove the object, detect the car. And that's it. Okay. And I'm excited to show you the final demo. So please let me show you. Yeah, the car's moving toward camera. Okay, the traffic light, and then if this direction now is blocking the sensor, it's busy, right? This direction is busy, so if remove that, it's clear, and then turn on the green light. You don't have to wait. Okay, David, please.
SWOT analysis. Strengths of our project are that it's mostly cost effective per intersection. I estimate that the cost per intersection would be, if they already have a camera system, around 40,000, maybe less depending on how much money you want to just kind of squeeze out of the city that you're working for. It has a larger detection range due to the way that camera systems work. So while as the electromagnetic coils can only detect a certain range, the camera can basically, well, detect anything within viewing range, which depending on the angle and how high up it is, can be actually quite far. Our weaknesses is decreased detection accuracy. As you saw earlier, it can be ironed out eventually, but for right now, our detection accuracy is a little bit iffy. It can get confused very easily on whether it's an actual car or not. even when it's up close. It has an increased maintenance frequency because of possible bugs that it can get. We don't want a traffic light randomly going haywire while someone's trying to commute to work. That'd be very problematic. The opportunities are advancements in machine learning. If you didn't notice already, we've actually been using a very, very simple AI to detect our cars. And our threats are, well, cybersecurity. Cybersecurity, well, since it's using a Raspberry Pi and therefore coding, it could theoretically just be, hacked into, and someone could turn a green light and they'd be able to legally run a bunch of lights, and that wouldn't necessarily be good for traffic either. Our project objective is to develop an intelligent traffic light system capable of efficiently detecting a waiting car at an intersection, allowing it to pass, decreasing traffic wait time as a whole. Final thoughts. In conclusion, our camera-based smart traffic systems focus on cutting waiting times on red lights whenever possible. Pre-trained model successfully has a detection rate of around 70%. The system uses only one camera due to parts availability and cost restraint. The Raspberry Pi 3 is not powerful enough to run an advanced AI program, hence the inaccuracy. Paper miniature may not be fully representative of the real life environment, and possible future improvements are to train our model to improve detection accuracy. That was one of the very big stepping blocks that we had to overcome. We couldn't actually make an AI from the ground up because we didn't have enough time to do so. We would also be adding IoT features for data analysis, such as the amount of cars that pass through an intersection, how frequently they pass through the intersection, in order to establish well-known traffic routes. That way we can maybe adjust the traffic light timing for those areas. And we would also be using a more powerful computer. These are our team members. These are what they did. And our supporting courses acknowledgement. We'd like to also we would like to express our special thanks and gratitude to our professors for supporting Tech 126 industry-based projects. Professor Sonia Farrell, Tech 121-02, Professor Shiva Kumar, Matt Pathy, Tech 126, Professor Mordezai, Professor Ichwa, Tech 124-02, and Professor Antols, COM 113-02. Q&A.
All right, that's great. Thank you.
It was really great. I really liked how you did a couple of tests and showed the YouTube video and the code. That was very helpful when you said each part of the code and how it showed the steps. That was great for me to understand that on the code. And the only question I have is, as a team, how and what you've learned working together, what would you do next time you work with a team?
To do it better.
Have a better. Oh.
I definitely increase the time.
I would say
Time management.
time management, that's number one. Project management, better communication for sure. So that way, it's better interconnected, who's doing what, And Olivia?
I can say really honestly, that would be like the main ones we need to focus on is time management, communication throughout the group, especially trying to work to get our time schedules matching up. Because I don't know about everybody else, but pretty much my whole group was here while I'm like hours away type stuff. So that goes into our time management and trying to schedule a time when we can all meet, because these three are pretty much in Fremont. And then I'm in Stockton, so that definitely put a little bit of a constraint on our, communication skills. But I think overall, like, we worked good as a team. Would we suggest doing this again in the little bit of time allotted? Probably not. Probably not. But we did okay. We're still all alive and, all in one piece. Put it that way.
It's a learning process.
Yeah,
Definitely.
gotta unlock the experience for that,
Yeah.
right?
There you go.
For sure.
Thank you.
Any,
So I just want to congratulate you guys for this great presentation. I love to see that you put in so much work.
We could show it right now, if you guys allow us.
He started clapping before we could finish.
welcome to come to our
I
project.
looked over and we only had like a minute left.
Yeah, the time and not,
But
So, but judges are more than welcome. To demonstrate for the project. No, And definitely everybody can see that. Yeah. I think it's just opening
Yeah,
up
okay,
so
good.
that we can
Okay.
see it.
Yeah.
Right? That's a good point.
Yes,
Yeah.
Yeah, so this was my architecture, police station and fire state building,
Yeah.
like, kind of like an abstract, model,
Yeah.
like that.
But the hardest part, I think, is to control the car moving slowly, does not cross the traffic light, because the car's moving so fast.
Or you're gonna do it.
With it.
We
have box. We just make it box.
Okay, so, we can ship it.
Maybe later, yeah, maybe later.
We can see it later, but what I'm
Okay.
just gonna say, it's good to see.
Okay.
Yeah.
No problem. Okay.
My question was gonna be, I don't know if you guys went ahead and think about this, I see the sensors right there and things like that, when the car was up there. I was just thinking, I couldn't help but thinking about the practical applications, right? Think of a real intersection here and things like that. Number one, how would you think of placing, a device like this in an intersection? I don't know if you thought about that already. And,
Yeah.
originally, if we had a little bit more time, the idea was to actually reprint a small actual representation of the traffic light, so that way the camera light here would be in a raised position. So that way the car wouldn't actually have any trouble with going underneath it. But unfortunately, time restraints just made it so that way some duct tape was the best choice, unfortunately. It's the same with the AI. If we had more time, we'd actually be able to make our own that is specifically for detecting cars. And it'd be a lot more accurate, but we didn't have that sort of time.
Plus, we had multiple other projects we were doing.
Yeah.
So there's that.
I just would like to add that, the project description was really clear, like, we were straight to the problem and to the solution, which is amazing, like, very, very easy to understand. The benefits of the project are also very interesting. And the coding is very, very clear as well. So as a team, you guys, how do you feel with the code?
Yeah, because I have some experience of computer science. I did a computer science courses before, so I have exposed to the Python before. So AI algorithm most is easy to use with Python for the beginner level. So I have never touched any AI thing before, but I just got to learn it. And the hardest part for me in terms of coding is how to run TensorFlow on Raspberry Pi, because we are using the 3rd generation. It's not the fastest model whatsoever, but we are able to run it, and it took me 2 nights to figure out how to do it. So, but eventually we are able to run it and perform the work quite well.
Yeah, I supported Jen.
Yeah.
Yeah, we literally stayed here in campus 2 nights at 10 o'clock. Yeah, sacrificing. Yeah, so Jen was focusing on the coding, whereas I was focusing on, yeah, like building the traffic light itself like this. It would have been done better, for sure. The wiring could have been, yeah.
Right, great, thank you so much. I must congratulate them. I never taught them on the AI TensorFlow, which is actually a surprise to me. I didn't know that you were implemented TensorFlow. That's great job. And Raspberry Pi 3, definitely we are going to get a Raspberry Pi 5 next time.
Oh, yeah.
Yes, our
new
new
iteration.
some Raspberry Pi. Hopefully, we are getting those cards. I know that Raspberry Pi is not a great model for our AI model. So thank you for the feedback and please preserve it. I'm a